Hello,
Hi.
how's it going? Be a true interview, okay? Because I didn't look at your questions, but I'm confident I can handle this. So let's do it.
Okay. Yeah, thanks for joining me today.
No
So,
problem.
first, I'm going to introduce myself and then you can introduce yourself.
Okay,
So,
sounds good.
I'm Ivanka, a high school student. I'm a junior. I'm really interested in climate and sustainability, especially methane emissions. And that's why I started this initiative, Methane Matters, where I aim to educate people on methane emissions and their impact and how to mitigate them. And so I'm doing a series on this channel where I'm interviewing prominent people in the methane space just to get to know like what work you do. And Dr. McFadden, you're the first one. So I
Oh,
got to know you because I did research in your lab at Cornell last summer and it was a really great experience.
well, I'm glad you had a good time. I mean, that's how I started. I started out as an undergraduate researcher, and now look at where I'm doing. So, yeah, I'm a dairy cattle nutritionist and biologist. I study the nutrition of the dairy cow and its effects on milk production and methane emissions. Our programs focus on various aspects of methane mitigation and monitoring, both here in the United States, but a significant portion of our work is also focused in India.
Yeah, thanks. Okay, so first question. So what's your background? How did you get started in
Yeah.
research?
Oh, a long time ago. So I basically am from New York. Always had a weird fascination with dairy cows. Didn't come from a dairy farm, but like studying dairy cows. And went to Cornell for undergraduate for my bachelor's degree. And when I came to Cornell, I just like most undergraduates, you want to be a veterinarian, and that's what I thought I wanted to be. Had a chance to work in a lab and really realized that I love all aspects of research. The discovery part of it, sort of being the first to know something, is really exciting feeling. And I worked with a mentor named Dr. Dale Bauman, and it's a small world because I sort of ended up in the position that when he retired, I sort of filled his role. So came full circle for me. But yeah, I think that's where I'm at now. And I've certainly, once I got the research bug, I sort of stuck with it for the long term, obviously.
Yeah, so I know you didn't always do methane in your lab. So how did you get started with methane?
Yeah, I think to be a successful scientist, you have to be able to diversify your interests. Science is constantly evolving. Right now, the topic is methane, but in 10 years, it'll likely change to something different. And so, a good scientist, I've always advocated, is somebody that can sort of predict where the future's going in a way, and be the first to really take on that field. I'm definitely not the first to take on the methane space, but when I came to Cornell, previously I was a biochemistry professor at West Virginia University, and yeah, I was a lipid biologist. I mean, my background is in lipid biology, studying fats and oils and their effects on the cow. And there's some relatability there to the methane space, but once I came to Cornell, I got tenure. When you get tenure, you almost want to reinvent yourself in many ways because the thing that you just studied for 6, 7 years is most likely starting to fade away in terms of a research interest, from definitely from a funding perspective. And I've always wanted to tackle some of the biggest questions in my field, and I think the third component is I've always teach my students to study the complete animal, and methane is really just one component of a very complex system. And so just because I'm studying methane now doesn't mean I'm ignoring lipid biology. It's all sort of interrelated in many ways. And so the I think that's sometimes hard for scientists because they get so dialed into their specific focus and their interest, and they sort of ignore the periphery. And we really work hard to not ignore the periphery and try to look at the whole system. So when I came to Cornell, there was certainly opportunity in this space. I mean, I don't need to tell you the focus on methane is strong, and there's a lot of funding in this space. And I took the first couple of years during COVID to really just to study the field, to understand what people were doing right and wrong, and not saying that they're doing wrong, but really trying to think about what's the best possible approach to study these things, and really not do my best not to compromise the sort of my scientific approach. And so really stick to my guns in terms of um, doing the best possible science that I can do. I also like big challenges, and this is a big challenge, so I'll try my best.
Yeah. So what exciting projects are you doing in methane?
Mhm. So right now in the United States, we really want to push forward bromoform. Bromoform is a halogenated compound. It works really well. There's other researchers that have demonstrated that either synthetic bromoform or bromoform within seaweed species like Asparagopsis texiformis work really well at inhibiting methane. But there are a number of concerns for the animal and the human that consume the foods. So we really need to think about the best possible, streamlined scientific approaches to push forward these kinds of technologies towards regulatory approval at a lightning pace. And we have to reduce methane quite quickly. The United States and other countries like in Europe really have to aim beyond a 30% reduction in order to sort of help compensate for other parts of the world that might not be able to reach that target or afford technologies. And so the bromoform or halogenated compound space is getting a lot of corporate investment. And we at Cornell have a lot of the resources, both from an intellectual perspective, but also from, a research perspective, from like having animals and the equipment to do these things at scale. And so we really have a series of studies looking at energy use, responsive bromoform use, looking at animal safety, food safety, and yeah, we're just started this process. It's a lot of hard work, a lot of studies. State of California is a primary sponsor on this. So we're doing that. There's other aspects of our program looking at other parts of the world that maybe can't necessarily adopt that kind of technology at the scale that's desired. And so my interest has been heavily centered on India. We have a little bit of work in Nepal too. But the goal there is just think about some basic practices that we already know work. Maybe they need to be tweaked in a certain way so it fits the system of the region. I never advocate for silver bullets that are applicable everywhere, but really take some fundamental knowledge about what we know about dairy cattle nutrition and efficiency and try to apply that in that region of the world that has a substantial number of ruminants.
Yeah. So when I was in your lab at Cornell, I saw the green feeds and the respiration chambers. So can you tell me about the equipment you have?
Yes. Yeah, I know it's crazy because I think 2019 we didn't have any of this equipment, and we moved at a lightning pace. And the way this started was when you write grants well, people know this and they come talk to you and they say, "Oh, you should write this equipment grant for the USDA." And I tried and I failed. I tried again and I failed a second time. But in that process, I really wanted a respiration chamber facility. These things are quite expensive to operate. At one time, there were, I think, 9 or 10 of these installations across the US, but that was back like in the 60s and 70s. Those things got decommissioned, and really, there's a real deficiency of that technology in the United States right now. And so we moved at a lightning pace to secure funding from the state of New York, Cargill, Balchem Corporation, and Genesee Valley Regional Market Authority. There's just over 2.2 million to build this facility. These are climate controlled respiration chambers, 1 cow per chamber. We have 4 of them. You can monitor feed intake and water intake in real time. And you can monitor gases like CO2, methane, hydrogen, and oxygen also in real time. These techniques this technique is sort of gold standard because you're measuring total gas emissions within a day. You're completely controlling the environment. You're completely monitoring intake, and you're monitoring all the gases emitted from that animal within a 24-hour period. Disadvantages: it's low throughput, very expensive to operate and maintain, but we have them. They're fully operational. Now, the alternative, and there's many different types of alternatives, but the green feed units are certainly the one that's getting the most traction. They're referred to as a head box unit, where a cow can put her head in a hood, some sweet pellets come out, so entices her to put her head in there. She'll eat the pellets. Second, that's my dogs. They'll eat the pellets and they can monitor. Sorry. Probably a squirrel or something. They can eat the pellets and monitor emissions, but only do so for a very short period of time. And so when somebody uses this green feed technology, you basically can only monitor emissions for about roughly 15 minutes a day on a good scenario. And so that might not actually reflect total emissions because emissions change throughout a day. It's not a flat line thing. When a cow has her first meal of the day, typically those emissions are going to peak in the early morning. And so then they'll sort of slowly, gradually decline until the next day. And so it really depends on when you use that system in terms of how accurate it is. And so we're trying to develop sort of correction factors for using green feed because it's a technology that's being used across the world. We ourselves have 3 of those green feed units at Cornell, and 2 green feed units are landing in India this week. It's been a long process to get them there, but it's the first 2 going to India, so we're excited about that.
Exciting.
It is exciting and challenging. There's a lot of paperwork when you try to move something like this. I never anticipated this much paperwork, but it is what it is. There's certainly other types of ways to monitor methane, like biomarkers, milk fatty acids. There's people looking at breath, looking at saliva, DNA of the microbes that's in saliva to see if it relates back to emissions. There's wearable sensors. There's all kinds of these technologies, but there's really a lack of science to demonstrate their accuracy. So,
Yeah. So we talked about this a little bit earlier, but based on your experiences and research so far, what are the most promising interventions that you've seen?
yeah. There's the take home there is that there's not going to be one strategy. I really believe that in the global north, you're thinking about technologies that could reduce emissions beyond 30-40%. And so really that's just halogenated compounds right now in terms of feed additives. There's another compound called 3-nitroxypropanol that's pretty consistent. You get about 30% reduction, at least in the front end of lactation. Long-term effects of these compounds we really don't know yet, but these halogenated compounds and 3-NOP are direct inhibitors, and they show a lot of promise for sure. I think you have to have an open mind though that we really got to. I'd argue that's a very limited number of solutions for a variety of reasons. One, the scalability of seaweed is very questionable. Synthetic bromoform has some safety concerns. And so you have to think about what else could we sort of leverage. And there's a lot of interesting things. I mean, there's lytic enzymes that I know that are being explored that really target methanogens. It's going to take a little bit longer to figure that one out, but there's a number of corporations thinking about this. We've got things like breeding strategies and use of vaccines, which will require a substantial amount of time to roll out. But those strategies are beneficial because the interventions required are very minimal. Whereas with the feed additive, you need to feed it every day. If you just grow, breed back low methane emitters, then that's something that can pass on generation to generation, and you can really change the whole system that way. In vaccines, you might only require a 1 or 2 time intervention with the animal, and you can have long-term impacts on that animal. So those are also holy grails in many ways because they have widespread utilization once they're refined.
Yeah, okay. So also AI has become a really big thing lately. So how are you guys using it in your lab?
Oh, when it comes to big data, I'm not the guy. Personally, I don't know. I'm a bit old school. I've never actually studied data science like those that are studying machine learning and AI now. But Cornell has a wonderful sort of group of colleagues that are in this space. So the way we contribute is by providing the data. I mean, I'm an animal biologist, so we generate the data and then we share that data. You are working with Dr. Emil Hostens, who is a data analyst, and he just received a substantial award to mine green feed data globally, I think from 50 different sites. And the goal there is to understand how to use green feed technology under different production systems. So developing protocols for how to use it to guarantee yourself that, or at least enhance your ability to provide a more accurate estimate of methane emissions. Data handling and use is something that is it's something that we put a lot more attention on now than I did 10 years ago. The old way of doing this is you get an Excel sheet, you have some notebooks, you put your data in it, and you're sort of done. Now you sort of have to have more refined data pipelines to sort of catalog your data the same way across multiple studies. And so this allows the creation of databases that could be used by investigators across the world. And so the team-based science from a global perspective has definitely changed, and it's more prominent now than it was a decade ago.
That's really cool. Okay, so my last question is, what advice do you have for high schoolers and people like me who want to go into this space?
Yeah, I think it's knowing that the space exists, to be quite
Yeah.
frank with you. I think when I was in high school, I had no clue. I had no clue that this world existed, okay? Especially if you don't come from an agricultural background. But there's so much opportunity in this space. There's so much use of technology and data. And so you could be a computer person, right? You could be an engineer. You could be, again, somebody that wants to be an animal biologist. And there's opportunities for all of those individuals right now in animal agriculture. And so I think just educating yourself about the opportunity that truly exists and exploring that opportunity to see where your interests lie, because you might discover that there's this field that exists that you didn't know existed, and that's where your interests truly lie. I will say too is that asking questions is really important, and taking time to form educated opinions about animal agriculture is something that everybody should do. I don't think that you'll have to be in the field to do that. When it comes to understanding food choice and what you decide to eat, I think it takes a little bit of time to really understand the pros and cons of a specific technology or practice and its effects on milk, the composition of the food, the cost of the food, the sustainability of producing that food has on that in that farm system. This is something that consumers typically are not educated about. They'll typically know one thing, or they might know something about you know large scale production farming and, let's say, animal welfare or manure production. They'll know one thing, but you really have to know that there's trade-offs for certain things, right? You might have a negative, but there's a reason why we're doing that, and there's probably another positive, or there is a positive that you're not talking about. And so really understanding why we do what we do in the animal world, because it's typically done to enhance efficiency. And that's good for the farmer because they need less resources. It's also good for the cow because you help meet energy requirements, you have healthier animals. And these animals are like athletes in a perfect sense. If you're using the best possible science, with the best possible genetics, management, and nutrition, you're managing an athlete. And so, yeah, those are the two things. No, high schoolers should know about all the opportunity that exists in this space, educate themselves. And then if you're not going to be in this space because you're going to go totally different field, at least ask questions about how food is produced so you're more informed about the practices involved in producing that food.
Yeah, thanks. So
Thank you.
that was my last question. Thanks
Oh,
for joining me today. It
Thank
was
you.
really to learn about what you do.
No, thanks for inviting me. I'm glad it was pretty cool that you're doing this. I think this is a great example of an initiative that's required to sort of educate people. So good job on you. And thank you for being in my lab for that short time. And
Yeah,
I wish you the best of success.
thank you.
All right. Thank you.